Hi, I'm Mr. Buckingham, and this video is on ecosystem changes and impacts. So off the coast of Australia, there is a huge coral reef, and that coral reef is changing, and it's likely to go extinct. So before there was any ecosystem impact, there were multiple species of coral and multiple species of fish. And now what's happening is that the temperatures and the acidity in the oceans are getting higher, and it's actually bleaching a lot of the coral, and it's causing a lot of death in the area. So go to Australia if you haven't yet and check that reef out because it might be going away soon. So in this video I'm going to talk about the impacts of the ecosystem and the human caused impact, which is going to be climate change and what's happening with the global temperatures of our Earth. And there's also a natural impact, geologic, and that can be an example of that could be a continental shift. And another impact is going to be our weather systems, and humans as well are kind of changing those. And one large one that happens in about every 5 years on average is El Nino, an intense heating of the equatorial waters. So global warming defined, which is also causing climate change. So on average, the entire Earth is warming, and it's caused because of our atmospheric, we're pumping a lot of molecules into our atmosphere, and those are starting to become larger and larger. So this yellow will be, and actually gray will be a better representation. All of those what's called greenhouse gases will accumulate there. So normally what happens is the sunlight will arrive at our Earth, and most of it will be reflected off of the Earth. But there is some that will be converted into heat, and it is reflected by our atmosphere, which is a good thing because that allows us to have a warmer Earth and not super cold. However, we have been pumping out a ton of these greenhouse gases, so more and more of it is reflected back to Earth. So then we see a global rise in the temperature. And what is making that happen? So the large ones that are causing this to happen are CO2, and this one CH4, which is going to be methane, and actually water vapor is also going to be considered a greenhouse gas. So this upper left figure is about 30 years of data, and we can see the red parts are going to be the increase in temperature, and the blue sections are going to be a decrease in temperature over those 30 years. And you can see on average, globally, it seems that there is a much larger increase, or more red, so an increase of temperatures in those areas. And you can see that the biggest change is occurring in some of the more northern regions, and that is going to be changing the ecosystems quite drastically in those areas. So some scientists in the permafrost areas, so permafrost is just going to be some icier regions or some colder regions. As those permafrost parts start to melt, what they see is that they will release the methane. And when it happens, that methane becomes like a blanket around those areas, and it will actually heat up to melt more of that permafrost. So one of the themes in this class is feedback loops. And this is going to be a positive feedback loop, just as the polar ice caps melting is a feedback loop. When we pump out more CO2, so as this concentration increases because we are burning tons of fossil fuels, that could be our cars, that can be our industries, that means that there's going to be more of that CO2 in our atmosphere, and that CO2 blanket will reflect heat back to our Earth, which is going to start melting some of the more ice in our area. And then water vapor, which you wouldn't think that would change or it would increase temperatures globally. So as water is in our atmosphere, it will actually heat more of our Earth, and then there's going to be more evaporative processes because it's slightly warmer globally. And you can see this this cloud cover is actually going to be a pretty warm day comparative, or a warm night comparative to if these clouds were gone. So if you've ever been camping or outside and there are no clouds in the area, it's actually pretty cold, but if there are clouds in the area, it actually retains a lot of that heat. All right, so this data from Intergovernmental Panel on Climate Change was written, I believe, in 2016, so I grabbed the data from there. And they are stating that if there's a 0.5 degrees Celsius increase, which we're actually experiencing right now, that a lot of the coral reefs are going to be damaged, and there is going to be some major melting and change to the Arctic ecosystem. So this little clip, which I'm going to play in a little bit, is called a calving event, and a lot of the ice structures are going to melt and they're going to break off. And this section is about the size of Manhattan. So I'll play and you can just watch how much change it actually goes through. All right, so if there is a 1 degree rise in temperature globally, there's going to be massive coral bleaching, and we're headed that way right now. So coral bleaching is when the algae and the coral no longer are functioning, and the algae is actually secreted out of the coral, and so that's why it looks white instead of all those different colors. And that means that that's coral death, basically, and they cannot, if the temperature is too high or too acidic in the oceans, then the coral will actually start to do this process. And we're going to see a 10% ecosystem of our planet, 10% of the ecosystems are going to be transformed. And the biggest ones that are going to be transformed are the ones in the northern regions. So in Canada, Alaska, and the arboreal forest, which is going to be in northern Russia. And those are going to see the highest temperature change, and the ones along the equator actually won't be changed that much due to the temperature rise. And then a 2 degree rise globally Celsius is going to actually change a ton, and we should try and avoid this at all costs. So coral reefs are going to be completely gone. The surface water, which is actually really important for us, so fresh water, not salt water, and needs to be fresh water, will be hard to find, and we need that fresh water for our crops. Animals need that to drink, and when we don't have much fresh water to irrigate, our crops and our farms are going to dissipate, and we're actually going to have a pretty large economy change as well, because we rely on those crops. 25 to 33% of all species committed to extinction, and extinction means that they are no longer, those genes are gone, that biodiversity is gone, and this is really bad for our ecosystems. At the end of the 21st century, 95% of ocean area will rise by 0.5 meters, and you might not think that's a large change, but a lot of our cities are on coastal regions because it's easier to do trade way back when, and still today. And if that rises, a lot of those cities will be submerged. So a geologic change, or a geologic process that is changing some of our ecosystems in the past is continental drift. So if you remember, we used to have this huge continent called Pangaea, and during that time a lot of organisms could go across this continent, And what happened over time is that continents started to drift apart. So marsupials exist in different parts of our world. Well, how did they get they're genetically similar? How did they get to different parts of the world? Well, they didn't swim there. What happened is that they were on those continents and were roaming around, but then when they split, they were segregated in different parts. So a marsupial would be this koala, kangaroo, and those two will exist in Australia. So you can see this orange, they were down here in Australia, and they could also go up a little bit here. And this possum would exist in South America. Well, as Pangea split, we have the animals in Australia way off, so this moved quite fast into the southern regions. So when that happened, they were in a completely different climate, because in that area it's a little bit hotter, or it might be wetter in the coastal regions or whatever, and so now they are going to have to adapt to the new climate once that shifts over. Another geologic process that can affect our ecosystems is volcanic activity, and this is Mount St. Helens that erupted in 1980, May 1980, I believe. And so what happened is it just totally decimated the forests around there. And when it decimated the forest, it actually could bounce back. It wasn't the worst thing in the world, because it was a localized area. So there are two different types of what's called forest succession. And succession just means that there's going to be different events or different times that the forest is going to bounce back to its original state. So we have primary succession, and primary succession means that there is no soil. And soil is needed for the microbes in the soil, for a lot of different organisms to rely on, and soil is needed for plants. And if there's no soil, then plants can't really come back, and the plants are needed for animals also to survive. So this picture is quite some years, and today we can see some shrubs, if you go hiking on Mount St. Helens, that have started to grow. Then there is secondary succession. Secondary succession could be, an example could be a fire. So this is in Yellowstone, the big Yellowstone fire years ago. And the soil has soil. It is still there. And there are still some organisms still there. So some plant life, some trees might survive. So this secondary succession is able to bounce back a lot faster. So you can see in not that many years that some of the pioneer species, which I'll explain in a little bit, are coming back, and they're starting to grow and start to replenish some of those soil reserves. So what happens, let's say that there is a fire in some area and it kind of decimates a lot of the plant life there. So the first species on the scene is going to be the pioneer plants, and these are usually going to be weedy species. They're going to grow really fast, they're going to die really fast, and they're able to live in low nutrient environments. So when that happens and they start to die, they give their nutrients, or when they start to decompose, their nutrients will be given back to the soil, and the soil will then start to grow a little bit more. And you can see the soil here is starting to accumulate as we go to the right of this figure. So after the pioneer plants, larger species and larger grasses will be able to grow because the soil is a little bit thicker. And then we have shrubs. So there's going to be a little bit longer, and shrubs will be able to last a little bit longer. And then we have short-lived pioneer trees, so shorter trees. And then the climax forest is going to have, it's going to be a large forest. So climax forest, there's a lot of them in Oregon, and we're trying to preserve those forests. So in general, as time persists and we have forest that has been affected greatly and there's not many species left in the soil, there's a little bit of soil that's workable, pioneer species are going to come in and then as they die off, they're going to leave nutrients for other larger organisms of plants until we get the climax forest. And then other organisms, such as animals, will be able to inhabit those areas as well. All right, and the last one, El Nino. El Nino can affect our ecosystems greatly because of intense heating in a few years. So every about 5 years, we have this event called El Nino, and it will warm our equatorial seas by a great amount. And what happens to the northwest is we see this huge warming, and those are going to be the summers, or those are going to be the years that are particularly dry and particularly hot. And what happened in our recent El Nino is that most of the California crops and most of the California areas saw a huge drought. And if that happens, that's really bad because people have to go on water conservation, and it's really expensive to use water down there. And then our economy is hit, and a lot of our crops then are going to be more expensive for us. And our California waterways, when they're affected, really affects our way of life in the Northwest. And so the years that is more normal is going to be La Nina. And you can see that it's going to be our wetter years, rainier winters, rainier springs, and which will replenish a lot of our water reserves. So right now we're not in as much of a drought in California and Oregon. Oregon wasn't in that bad of a drought, but California definitely was. And this year, 2017, this spring, California saw a ton of water, which is a really good thing. Back to La Nina. And that's it. Thanks for watching.